Sketching polynomials, things to look for. Well, the y-intercept's always going to be the constant. So if I was going to draw this one, the constant, remember, I don't have to expand the whole thing out. I can just look at the constants. So it's 1 times -1 cubed times 2 squared, which is -4 is correct. So there's our y-intercept. The x-intercepts are the roots, the zeros, the solution to the equation. Fortunately, this one's already factorised, so we can find those answers quite easy. We have -1, 1, and -2. Okay. When we're looking at the extremities of a polynomial, the only thing we really have to look at is the leading term. Because out at infinity, a function will behave, or a polynomial anyway, will behave like the leading term. And I guess that's because when you talk about really, really big numbers, a power of 3 is so much bigger than a power of 2 that the power of 2 is insignificant. And then when you talk about higher powers, again, obviously more of an effect. Let's have a look. We've got x times x cubed, see if we can get this one right, times x squared.
X power 6.
X to the power of 6 is good. Now, if I was to ask you to draw x to the power of 6, you would start, well, up there. And you would finish over there. So we know our polynomial is going to do that. Okay. Now, the actual roots themselves, when they're factorised, the x-intercepts act like the power. So however that would act like. So if it factorises to an even power, I know it's just going to come down and touch it, like an even one would. Now the higher the power, remember, the steeper the side, the flatter the base. Now we have an even one over here, x plus 2 squared. So at -2, I know it starts up here, so at -2 it must do something like that, some sort of U shape. Odd powers, again, will act like the power. So I have that inflecting happening, the horizontal point of inflection. Other than power of 1, of course. Power of 1 would act like a straight line. It'll just cut straight through it. So at +1, we have a cubic. So I'll do through there. It'll cut just through -1. I know it's got to go through -4. Now, if we wanted to, we could use some calculus and find those turning points exactly. But there it is as a sketch. If it completely factorises to be a perfect factorisation, so just one term to a power, then we know basically we've got the basic curve. But it's just been shifted to the left or right, however many units. Okay, let's do this one. X minus 1 to the 4, x plus 1 cubed, x plus 2 squared, x minus 2. What's the y-intercept?
-8.
So yes, it's -8, but we can also confirm the other features now. I'll put the graph up there. We know we have a quartic at 1, and that's why you'll notice here it's flatter at the base, a bit steeper at the sides. We've got a cubic at -1. We've got a parabolic at -2, and just a straight line at 2. And again, if we wanted to find the exact location of those turning points, well, calculus could do that for us. Okay, that'll do it.